Yes, I do.
You do. Okay. All right. So how good are you with graphing sine and cosine functions? You solid with that? I couldn't hear you. Did you say you're good? You're good with graphing sine and cosine functions? Oh, I lost you. All right, do I have you back now? You back here?
Yeah, I'm back. Sorry.
All right, no problem. Are you good with graphing sine and cosine functions?
Yeah. I
No?
think no, not yet. I think I can practice a bit more with that.
Okay. So the key with secant, to graph a secant function, is you have to first graph the cosine function and then use it to graph the secant function, because the secant is the reciprocal of the cosine. Okay.
Yeah.
And in fact, let's talk about how you graph it. And I like to explain this with a unit, with a unit circle. In fact, I just did this the other day for my son. So I'll just pull that up and show you what I did. See if this is the one. Maybe this isn't the one. That's not it. Let's see. Oh, it wasn't shared with me. It's going to be recent. I think this is it. Yeah. So I was explaining this to my son the other day, and I was showing him. So you can watch this video later, but I'm just going to refer to it.
Right.
You can see how if you take your unit circle here, which I've got up here, if you take your unit circle and you convert it to a Cartesian plane. So for example, with the blue graph is my sine graph. So what I'm doing is I'm taking and I'm plotting the radians against the value of the sine of x. So x is radians and y is sine of x. So if I do that, what I will have, and you can see it up here in my unit circle, the sine is your second coordinate, right? The sine is the y coordinate, right? So when the radians are 0, here's your radians and here's your sine. So I'm graphing 0, 0, pi over 6, 1/2, pi over 4, root 2 over 2. So you go over here to this blue graph, you can see that that's what I'm doing. Not only that, but you can see what your quadrants are right on your graph. You can see that the first quadrant would be right here. That would be my first quadrant because it's from 0 to pi over 2. You got it? My second quadrant right here is from pi over 2 to pi. So here's pi over 2 to pi. That's my second quadrant, right? Represented on the graph right here in that region. You follow?
Yeah.
And you can continue going. And you'll notice that if you go to the left, this is going to be your fourth quadrant from 0 to negative pi over 2. See how 0 to negative pi over 2, this is also could be considered negative pi over 2 if you're going this way. You see how that's your fourth quadrant? So again, graphing these points, negative pi over 6, comma negative 1/2, negative pi over 6, comma negative 1/2 is going to be right here. Negative pi over 6, negative 1/2. It's going to bottom out at negative 1. It's going to go through 0 at negative pi. And also at positive pi, right? If you're going to the right, and it's going to max out at negative 3 pi over 2. And the max point will be 1. And also it's going to max out here. So it's a periodic function, right? It's just going to keep doing that same thing. That's why it's called a periodic function. And so a lot of times they'll ask you to graph 2 periods of the function. So 2 periods, you could either start here and keep going like this, or you could start here and go forward 1 period and backward 1 period for that sine function, for example. Okay. But if you do that, you can see I like doing that. I like graphing this with the unit circle, and I like graphing all the different functions so you can see what happens. Look at the red graph. That's my cosine graph. You see how the cosine graph starts up at 1? Because remember, the cosine is your x coordinate. See how it starts at 1 and it goes down to -1 at at pi. I'm sorry, goes down to 0 at pi. So it starts at 1. I'm sorry, it is -1. Goes to -1 at pi, and it cuts through 0 at pi over 2. Okay. So that's what's happening with the cosine graph. The tangent graph, this is again why I like doing it like this. The tangent graph, which is in yellow here, remember the tangent is the sine over the cosine, right? So it's the blue divided by the red. At every point, it's blue divided by red. So 0, that's the blue, divided by 1 is 0. So there's my yellow dot. My tangent of 0 is 0, right? Where the two cross, where the blue and red cross, that's going to go through 1, which by the way is pi over 4, right? And where the blue and red let's see, where they're opposites of each other, which is going to be right here. That and that are opposites of each other. One's a positive, one's a negative, and that's why it's at -1. The yellow graph's at -1 right there. And you can keep, like I said, you can keep doing this for all the values, and notice that the period of a tangent graph is pi, not 2 pi, because it repeats every pi units it repeats. And the reason, a good way to think about that is because you're going to have asymptotes. Every pi units away, you're going to have asymptotes. For the tangent graph, the asymptotes are going to be at pi over 2 and at -pi over 2 plus or minus pi. And the reason, again, is because the tangent graph has a cosine in the denominator. So wherever the cosine equals 0, that's where you're going to have a vertical asymptote for tangent, because you can't divide by 0. Whereas the cosecant graph is going to have asymptotes where the sine is equal to 0, because cosecant is cosine over sine. I'm sorry, I'm saying cosecant, cotangent. Cotangent, the black graph, is cosine over sine, right? That's cosine over sine. And so you're going to have asymptotes at 0 plus or minus pi. Okay, you follow that?
Yeah.
Also notice something else about this. See how this is my first quadrant? Remember how the tangent and the cosine, or cotangent, sorry, tangent and cotangent are both positive in that quadrant? See that?
Yeah.
The tangent is going up and the is increasing in that interval, and the cotangent is decreasing in that interval, but they're both positive in that.
Oh, your screen stopped sharing.
What's that?
Your screen stopped sharing.
Oh my gosh. This whole time it hasn't been sharing?
It was sharing for a bit, but I don't know what happened.
Okay. Let's get it sharing again. I don't know how that happened either.
Okay.
Did you catch most of what I said though?
Yeah.
Okay. You understand, you're able to look at this.
Yeah,
Well,
I
maybe
can see what happened.
You probably can't. I haven't shared this Jamboard with you, but you can follow what I'm saying, right?
Yeah.
So I'm going to refer to that as I talk to you about your questions. So here we have the secant. You want to know what the secant function is. Well, the first thing we have to graph is the cosine. We have to graph g, let's call it g of x equals 4 cosine of 5x. So remember, this has to do with the amplitude. this has to do with the period. And the hardest thing about this, well, that's not the period. That's B. Period equals 2 pi divided by 5. That's how you find the period. Okay. So the hardest part of this is to find your intervals. So the intervals are always going to be whatever your period is divided by 4. Those are your interval lengths. Sorry, these are not your intervals. These are your interval lengths. Okay, so the period over 4, which is 2 pi over 5 divided by 4, which is 2 pi over 10. I'm sorry, pi over 10. So the interval lengths are pi over 10. Okay, and then what you want to do is you want to start with your shift, which in this case our horizontal shift is 0, so that makes it easy. So start with your horizontal shift. There's your first one, and then keep adding. This helps you find your intervals. 0 is your first one. Pi over 10 is your second one. 2 pi over 10, because I'm adding the interval length, right, is your third. They're your third, not your interval. These are your interval markers, I should say. So there's 5 interval markers because there's 4 intervals. That makes sense?
Yeah.
So your next one is 3 pi over 10, and your last one is 4 pi over 10. And again, we could reduce these. So this is pi over 5. This is 2 pi over 10. So these are my interval markers. So when I go to my graph now, I always just put my markers on 1, 2, 3, 4. And I draw those values in or write those values in. So that's obviously 0. This is pi over 10. This is 2 pi over 10, which is pi over 5. This is 3 pi over 10. And this is 4 pi over 10, which is 2 pi over 5. Now my amplitude is 4. So it's going to go up to 4 and down to -4. And since it's a cosine graph that I'm looking at, right, the yellow is my cosine graph. The cosines start at the top and end at the top. They bottom out in the middle, and they go through the central line. What does your teacher call that? Midline? I've heard it called midline before. I'll say that. It goes through the midline at the first and third points, or second and fourth, sorry, second and fourth points. Here's your first, here's your second, here's your third, here's your fourth, and here's your fifth. So, right, it's going to go, it's a periodic function, so it's going to end where it starts. It's going to bottom out in the middle, and at points 2 and 4, it's going to go through there. So your cosine, remember, this is your cosine graph. So I'm only graphing this so that I can use it to graph my secant graph. So now how do I graph the secant graph? Well, let's do this in red. So your secant graph, wherever it goes through 0, remember what we talked about before, the secant is 1 over the cosine. So if the cosine is 0 here and here, that means the secant is undefined, which means you're going to have a vertical asymptote. Got it?
Yeah.
Where the cosine, wherever the cosine is the maximum, the reciprocal of that, it's basically going to be this same point right here. And then it's going to be approaching those asymptotes, kind of like, it's not a parabola, but it's like a kind of like a rational function would have done. So our graph looks like that. And again, that's just one period, but it's going to be continually, it's a periodic function. So to check it, plug in pi over 5. Just to check these points, let's plug in pi over 5 into that. What's 4 secant of 5 times pi over 5? 5's cancel, you get secant of pi, which is -1. And 4 times -1 is -4. And yeah, there it is, -4. Pi over 5 comma -4. You can do that for other points as well, but that's just do it for that one to kind of make, double check for yourself that you did it right. Okay, good.
Yeah.
All right, now the cotangent graph, remember what I talked about before? On the last one, remember how the cotangent graph does not exist wherever the sine is equal to 0, and the sine equals 0 at all of at 0 plus or minus pi. So that's where my asymptotes are going to be. And the cotangent graph, remember the normal cotangent graph, I'm going to draw it up here. Cotangent of x, y equals cotangent of x, it looks like this. It's got asymptotes at pi and at negative pi. And it goes this direction. I'm sorry, 0 also. So it's going to go like this. Because remember, this is your first quadrant. This is your second quadrant. And the cotangent is positive in your first quadrant and negative in your second quadrant. Okay?
Yeah.
Same with this. It's going to go like this. Because this is your fourth quadrant here. Remember, the cotangent is negative in the fourth quadrant and it's positive in the third quadrant, which is right here. So you see how that's your third quadrant, that's your fourth quadrant, that's your first quadrant, that's your second quadrant. You can obviously keep going to the right too if you want. You don't have to go to the left, but that's it. Okay. So now let's take a look at this particular example. Well, for this one, your period is equal to pi over b. And b in this case is just 1. It's the number coefficient of the x. So this is just pi, which is nice. So the cotangent is pi, but notice that it's got a negative here. So what that means is it flips. Remember, when you make that negative, you're flipping it. Whatever was originally positive now is going to become negative. So it actually looks more like a tangent function.
Yeah.
A positive tangent function, right? And then this plus 5 just shifts everything up 5. So what's going to happen is, and here's how I actually prefer to do it. I draw in y equals 5 right here, and I make that and so my x-axis, because I hate when they draw in the y-axis and the x, well, not the x-axis. I hate when they draw the y-axis in. So there's my x-axis right there. And there's y equals 5 up there. The reason I do that is because now it's easier to graph this. I know that it's going to go through at positive pi and at negative pi. And this is 0. But remember, everything got shifted up. So your midline right here, your midline, like where it goes through 0, is all the way up at 5. So my midline, which is going to be at pi over 2 and negative pi over 2, that's where it goes through your midline normally. So it's going to be there and there. That's where it's going through. And let's draw in our asymptotes. There are asymptotes. Got it? And then it's going to be going, because of the negative here, it normally would have gone like this, but now it gets flipped and it goes like this, like a tangent function. Looks more like a tangent function graph. Okay, so my graph goes like this. And if you want a specific point to put in there, a good point to put in there would be pi over 4. Let me show you where that would be. Remember, pi over 4, your tangent at pi over 4 is positive 1. Remember that? Because pi over 4 is 45 degrees. So the sine divided by the cosine is just 1. Got it?
Yeah.
So that's 1 away from, it's basically 1 away from, so there would be 4. It's 1 away from your midline because there's no stretch in this. So pi over 4, comma 4 is going to be one of your points. 3 pi over 4, comma what? You follow what I'm saying?
3 comma 4? Or
It
no?
would be 6
Oh yeah, yeah,
because it's
6,
1
sorry.
away.
Oh
It's
yeah.
1 away, right? So that's 3 pi over 4. And so I'm only doing that because that's something you can check. Let's plug that in and check. What's the negative cotangent of pi over 4 plus 5? Well, the cotangent of pi over 4 is 1. So that's negative 1 plus 5, which is positive 4. Got it?
Yeah.
See how that works? So there's your cotangent graph and how to graph it. So now they're probably asking, write the equation for this graph, right? And there's 2 different equations you can write. You can write either secant or cosecant, because this graph right here could either be sine or cosine. So I'm going to just draw it in. As you can see, it's going to go like this. Your original function would have been like this, right?
Yeah.
So you can see that looks like what kind of a graph? What's this blue one look like?
The blue
Is
one
it
is the
cosine or sine?
it's a sine graph.
Well, it could be a sine graph, but that would require a shifted.
Oh, then it's
We
a
would have
cosine
had to.
graph.
I mean, you can do sine, but it's harder to do sine. It's easier to call it cosine because see how it starts on the y-axis. See how it starts up at the top. That's I would prefer to do it like that. That way, I don't have to do a shift. There's not going to be a horizontal or a phase shift if I choose to call it a cosine graph. So I'm going to write y equals cosine, and now let's fill it in. Well, you can see that it's the amplitude is what? Normally it would start at 1, but it's starting at 2. So what's the amplitude? It's going to be 2.
Yeah.
Okay, got it.
Mm-hmm.
We don't have a phase shift, which is nice, but I'm going to put dx. And am I going up or down at all? Am I doing a vertical shift at all?
No.
Look at your midline.
The
Your midline is
midline.
actually right at the
Yeah, so it's
x-axis.
not
So
a
there's
vertical shift.
correct. So all I have to do is figure out what b is. And how do I figure out what b is? The period
Yeah, 2
equals,
pi over
what does the period equal?
2
That's
pi
right,
over
2 pi.
b.
Very good. And so now let's solve it. Let's look for the period. What's the period? It goes from here to here. So what is that distance from here to here?
That's the amplitude.
Mm-hmm. Nope, not the amplitude.
Oh.
What's this distance?
Oh, it's the period.
And what is it?
The period is 2 pi over. It's 2 pi over
Nope, look at it. Tell me what this distance is right here to here.
Oh, here to here. Okay, that's 0.6. I can't see the last number.
It's 8.
8. Okay. 0.8.
So your period, so I'm sorry. I said that wrong. I mean, this is true, but b equals 2 pi over the period. B equals 2 pi over the period. And the period is 8, so b equals pi over 4. Okay, so the blue graph is 2 cosine pi over 4 times x. That's the blue graph, right? But that's not what they want. What do they want?
They want the yeah, they want it for the secant graph.
That's right. So what do I write? What does f of x equal? So the whole reason I did that is because now I can answer the question. And the question was, what is the black graph? So can you tell me what to write for the black graph?
The black graph, It's 2 cos pi over 4x, or 2,
Nope, it would be
secant pi over
very
4x.
good. That's it. That's your answer. Okay.
Mhm.
All right. You try this one. Tell me how you're going to do this one.
Uh,
What's the first step?
First step is look at the asymptote. The asymptotes.
Can you tell what kind of graph it is?
The tangent graph,
How do you know it's tangent, not cotangent?
because it's going from low to high.
Good. Okay. So it's a tangent graph. So what now?
Um,
So for a tangent graph, we have an amplitude. We still have an amplitude, and we still have a b, and we even could have an x plus c. X minus, what do they do? Minus c or plus c? I can't remember in your book. They do minus c plus d. This is my phase shift. Is there a phase shift here? Do I have a phase shift in this example?
no, there's no phase shift.
Good. So this just equals 0.
Yeah.
How about D? Is there a vertical shift?
There's no vertical shift.
Good. So that's also 0. That makes it easy. How about B? Remember, B equals 2, sorry, not 2 pi. B equals pi divided by the period,
right.
right? In a tangent graph. You know that?
No, I actually didn't.
Yeah. So that's what I was talking about earlier when we were looking at those other pictures. The period of a tangent and a cotangent graph is only pi. The period of a sine and a cosine and secant and cosecant graph are 2 pi. So that's one of the differences. B for this is going to equal pi divided by the period.
All right, yeah.
And the amplitude is kind of determined by where that point, it's like the stretch. So the amplitude is like the stretch. It's harder to find the amplitude on this, but like I said before, do you see how if I go halfway in between here, that would be like your 45 degree, and so you would expect to go up 1. So that tells me that there's no stretch. Do you see what I'm talking about? That's how you can tell if there's a stretch or not. So go halfway between the 0 and the asymptote, and then go up to 1. And if you have to go up higher than 1, then that's a stretch. If you have to go up less than 1, then that's a compression, which means a would be a fraction, like 1/2 or something. Follow what I'm saying there?
Yeah.
So my stretch is 0. I'm sorry. My a is 1, not 0. And so the only thing to do is to find out what b is. So tell me what b it would be. How do I calculate b?
You calculate B by so the period is it goes from -4 to negative pi over 4 to pi over 4. So the period is 1.
Nope, that wouldn't be 1. What's the distance here?
Oh, 2. That's 2 then. Or
Nope, it has pi. It has a pi in it. Or are you trying to calculate b for me? Tell me what the period is. Don't tell me what B is. Tell me what the period is. What's
Period
this
is
distance from here to here? This distance is pi over 4, and this distance is pi over 4. So that's 2 pi
the
over
2 pi
4,
over
which
4.
is
2 pi over 4.
what?
That's the period.
And what is that? What
Pi
is
over
2
2.
pi over 4
Pi over
simplified
2.
to? Good. So my B, I'm trying to calculate B, and look at my formula. B equals pi divided by, period again? Pi over 2, right?
Yeah.
And how do I simplify this? Flip and multiply, right? Those pi's cancel out and you just get 2.
Yeah.
Which I think maybe that's what you're trying to say before, but I wasn't looking for B, I was looking for the period so that I could see that you know how to find B. Okay, got it?
Yeah.
So what's my equation? Tell me what to write for f of x equals. You thinking about it? You still with me, Meher?
Yeah, I am. I was just thinking about it.
Okay, that's fine. I couldn't tell if you were thinking. So we're basically just writing out. We just figured out all these things, right? So we just write it out. So what do I write out?
So it's sorry. It's tangent of 2x. Yeah, just tangent of 2x.
That's it. Good. That's it. All right. Tell me what to do. I'll draw it in, but you walk me through it. Tell me what I do first for this one. We're on page 5.
So there's no horizontal shift. There's a vertical shift of 1, so we can put an amplitude at 1.
Okay. You sure the amplitude's 1?
Oh, I mean not amplitude. I meant the middle of
The
the
midline?
graph. Yeah,
The
midline.
midline? Okay.
Yeah,
Let's
the
call
amplitude
this
is
the midline.
-2. All right.
Right. Let's call the midline right here. Okay. And
Okay.
so I'm going to draw in a new, there's my new x-axis right there. So this is my x-axis. Okay, there's my midline. Here, let me even make it a dotted line. Okay, there's my midline. Now what? What's the highest I go to? I think you were just referring to this, weren't you?
Yeah, that's what I meant.
So what's the highest I go to?
3.
Okay. So there's 3, and what's the lowest I go to?
-1.
Good.
And it's gonna be flipped.
Okay, so what should I graph in here in yellow? What should I graph? G of x equals -2 sine or cosine?
Sine.
Good. Sine x plus 1. Good.
Yeah.
Good.
Okay,
And what's the
so
period?
the period is 2 pi over b, so 2 pi over 1. It's just 2 pi.
Good. So here's 2 pi. Let's call 2 pi right here.
So it would be
Let's call this pi. Pi over 2.
Yep.
3 pi over 2. So my graph is going to look like what? Where does it start? A, B, or C?
It'll start at B.
That's right. B of the choices I gave you. Where does it end?
It ends at B.
Good. How about at pi over 2, what's it going to be?
And it goes down.
That's right. Good. It goes down because of the negative. Very good. Because of that negative, it flips over. It goes down. Good. And how about at pi?
And it goes back to the middle.
Good. Perfect. And how about at 3 pi over 2?
At 3 pi over 2, it goes to 3.
Good. Excellent. So there's my graph. Again, I'm drawing this in, but really, this isn't really part of the actual graph, right? It just helps us graph the function, right?
Yeah.
So now how do I graph this actual function? I'll graph this function in red.
So there will be an amplitude whenever the sine graph touches the midline.
Okay, so I think you mean an asymptote.
Yeah.
Excellent. And now what?
And
What now?
the behavior of the graph within the asymptotes.
Give me one of the points that I should plot.
Um,
Pi over 2, where should pi over 2 be?
pi over 2 should be pi over 2 negative 1 still.
Perfect. And then graph it like this, right?
Yeah.
Okay, how about another point?
3 pi over 2 and 3.
Perfect. And going up.
And then it
You
goes
got it.
up. Yeah.
Yep, good. That's it.
Yeah.
And then again, you could go ahead and erase this, or I don't know if your teacher wants you to keep the yellow line or not, but
All right. Yeah.
good.
Yep.
Well done. All right. Oh, this is tricky. I'll show you how to do this, and then maybe we'll find another one for you to try. Okay. Because these ones are these ones are the trickiest when they do this to you. So the first thing that I would do is I would factor out. I always like to write them in this form, in y equals a cotangent of b times x plus or minus c plus or minus d. That's how I always like to write them. See how they didn't write it that way? They have this inside here. So my strong recommendation is you learn how to just factor that out. So this is just the cotangent of pi. I'm factoring a pi out, so I'll have an x plus, well, if I factor a pi out of there, I'm going to have a 1/2, right?
Yeah.
Just divide pi over 2 by pi. That's how you do that.
Yeah.
So that to me looks a lot better, a lot easier to deal with, because now I can see, oh, this is just the cotangent is pi. I'm sorry, the period is equal to pi over b, and b is pi. So the period is just 1, right? And then this means that it's shifted. See how it says a plus in there? That means it's shifted left 1/2 from the normal place. Okay.
Yeah.
So normally the cotangent graph, remember the cotangent graph normally starts at 0 and goes to pi, right? But now it's going to be starting instead at, you're shifting it left 1/2. So here's 1/2 or negative 1/2. There's my asymptote that was normally would have been at the y-axis. And the period is 1, which means it's going to go all the way here to positive 1/2. And that'll be my next asymptote. And then it's going to go, there's the midline at 1, and then it's going to go to 1.5 or 3/2. It's going to be your next asymptote, etc. Do you follow?
Yeah.
And because it's a cotangent graph, does it start on the top going down, or does it start on the bottom going up?
Starts at the bottom going up.
Think about cotangent.
Oh, it starts at the top going.
Yeah, cotangent goes down from left to right. The cotangent graph goes down from left to right, the basic cotangent graph. So it's going to go through this point, and it's going to come like this. It's going to start here and come like this, etc. Okay. And again, it's not a bad idea to plot some points in there. Let's use this point to test. When I plug in 1, what should I get? When I plug 1 in to this, what should I get?
Yeah,
I should get what? What's 1? 1 comma.
1,0.
Good. So let's see. What's the cotangent of 3 pi over 2? Cotangent is, remember, that's the cosine over the sine. And the sine, or the cosine of 3 pi over 2, remember your unit circle, that's the bottom point. The point negative, it's the point 0, -1. So 0 over -1, which is 0. Hey, that worked.
Yeah.
-1, 0. I'm sorry, 1 comma 0. That worked. Good.
Yeah.
Okay. Let's see. You give it a shot. You try one now. Find another problem, or do you want me to write one out for you? These haven't really been challenging ones quite yet. You looking for one?
Yes, I am.
Okay. Find one?
I'm putting it.
Okay. If you want to just tell us, I can write it in.
I know it's a word problem.
Oh, okay.
I just added something. It's not showing up on the screen for some reason.
See, sometimes I have to close it down and open it back up. There it is. All right, classic Ferris wheel problem. Before you start, give an estimation interval of how high you'll be after
Yeah, that was
being
just
on
the
the
thing
wheel.
because we were doing like an in-class kind of competition.
Oh, got it. Okay. So
Okay, I
we
can
don't have to
delete
really
that
do
because I
that.
didn't know what that said.
Okay. So as you ride the Ferris wheel at Navy Pier, your distance from the ground varies with time. After you sit down and get settled, you start your watch. You don't know exactly what your height is, but it's around the position in the figure. Okay. So that's where you start. Let T be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 3 minutes to reach the top. Okay, so it says, so we're going to do it like this. It's 153 feet above the ground. So that's the top. So that's going to be the top of your, the height, the max height, right? And that the wheel makes a revolution once every 7 minutes. So 7 minutes is your period. Period equals 7 minutes. You understand where I'm coming up with that?
Yeah.
The diameter of the wheel is 150 feet. Okay, let's see. I don't really see the question. Do they just want you to like write an equation for it? For your
Yes.
position at time t, I assume?
Yeah.
Write an equation for your position at time t. Let t be the number of seconds that have elapsed. So we could convert this to seconds because we're talking in seconds. So your period is 60 times 7, which is 420 seconds. Okay. The diameter of the wheel is 150. Okay, so that means if the diameter is 150, that means you started at 3 feet. You follow? 3 feet off the ground is where you started. I don't know if you started there, but that's the lowest it ever goes. Right? So to find the midline, which is also going to be your D, your vertical shift, how would I find this midline right here? Any ideas? How can I use these two numbers to find what the midline is?
You divide it by 2, so it would be 75.
It would be 75 plus 3, right?
Yeah, true.
So 78 is your midline. Got it?
Yeah.
So that's also your A, B, C, D, right? We're going to go, let's write this in terms of sine. Y equals A sine B x minus C. Well, we know C is just going to be 0 because we're not shifting it. Plus D. So D is 78. You see how I'm adding 78? I'm starting at 78. Got it?
Mm-hmm.
And what's your A? Is an A this distance here? And this distance here?
Yeah.
So what is that distance?
That distance is the amplitude.
Which is what?
75.
Good. So this is 75. And what's the only thing we have left to find?
Sorry, I don't think I understand the question.
What's the only thing we have left to find? We have A, we have D. What's the only other thing we have to find now?
B.
And how do I find B?
Um,
B equals what?
the time it takes for the
But what is B equal to? We've talked about it before. What's b, this number, always equal to?
This number is equal to the
Think about what we did on the other
pi
problem.
over 2 pi over b. I mean pi over the period.
2 pi over the period. That's right.
Mhm.
2 pi over the period. And what's my period again? What the problem say my period was? Read the problem. Tell me what it said the period was.
Period is 7 minutes.
Good. Or 420 seconds. So I don't know what the problem, if the problem wants it to
It's
be in
in
minutes
minutes,
or
I think.
seconds.
I think it's in
Minutes?
minutes.
Okay. Okay. So your b is going to be 2 pi over 7. So what's my formula? Y equals, tell me what to write.
You would write 2 7 equals 2 pi over b.
Nope, I want the whole formula now. We've already found all the things. Tell me what my equation is. Y equals,
Y equals 75 sine 2 pi over 7 x plus 78.
perfect. You got it. And that's your equation. Okay, see how we did that? Yes, good.
Yeah.
All right. Do you have another problem? Got about 5 minutes left.
Let me see. We can go over graphing regular cosine, I guess. Actually, no, I think that'll be fine. Let me look. Okay, I'm adding another one.
Okay. All right, a portion of a roller coaster track is to be built in the shape of a sinusoid. You have been hired to calculate the lengths of the vertical timber supports to be used. The high and low points of the track are separated by 50 meters horizontally and by 30 meters vertically. Okay, so I like to draw it out like this. The high and low points are separated by 50 meters horizontally. So here's 50. So let's go 0 to 50. High and low. Okay, so let's say that this is the high point and this is the low point. Do you see why I'm doing that? This is going to be a cosine graph. And by 30 meters vertically. So this is going to be, what distance is this going to be here? This full distance? What did it say?
It says it would have to be 15 meters. 15 meters.
That's right. Very good. This would have to be 15 up here. Excuse me, and this would be negative 15 down here. Yep. It says the low point is 3 meters below the ground. Okay, so that means that I have to subtract 3 from all of these things. Okay, so this is going to be 12. This is going to be negative 3, and this is going to be negative 18 because they just told me to shift it all.
Oh, I thought the bottom part of the graph, the negative 18 would be the 3 meters, but negative 3.
I'm sorry. Yep, you're right. I said that wrong. The low point is 3 meters below ground. Yeah, you're right. I did that wrong. So I'm shifting it up 12 actually, right?
Yep.
So let's shift everything up 12. So this is negative 3. adding 15 to that means that this would right here. So here's 0 is really right here. Right, there's my x-axis. So this point right here, that midline is actually at 12. And what's the top line at? 27.
Yeah.
That makes sense? Yeah, good. So that this is just half of your period, right? So what's your full period? It says the track is separate by 50 meters horizontally. The high and low points are separated by 50 meters horizontally. So that means that that's half of your period. So this means that your period equals 100 meters. Follow that?
Yeah.
See how I came up with that? So it says let
Uh,
y be the number of meters the track is above the ground, and let x be the number of meters horizontally from the high point. Okay, so this is my high point. We started there, so that's good. Let y be the number of meters the track is above the ground. Good, which we kind of already did that. And x be the number of meters horizontally from the high point. Write the particular equation expressing y in terms of x. So they want us to write this equation. So what would the equation be?
it would be y equals 15x.
Cosine 15.
I mean 15 cosine x.
Oh, yep. I got to find
Wait,
b, right?
yeah.
So what's b equal to? 2
B is
pi
equal
over
to
2 pi over the period, right?
or the 2 pi over b is the period.
Both are true.
Oh, okay.
If you want to find b, it's 2 pi divided by the period. If you want to find the period, it's 2 pi divided by b.
All right.
Got it?
Mhm.
So what's my b? I already did it for you. What did I write? Pi over 50. Right? Pi over 50, then what? What do I write? I'll help you out here. Pi over 50x, and then what? Is there a shift? How much is it shifted?
Yeah, there's a horizontal shift. No, there's a vertical shift.
There's a vertical shift of what?
12.
That's right, 12, good. So there's your equation. Okay. Good.
Yeah.
All right, well, that's it. That was helpful. Keep practicing, and I'll see you next time.